All right, starting 2.5, solving compound inequalities. Compound simply means you're combining two inequalities. So for part A here, we have to write each sentence as an inequality and graph each inequality. All right, so for part A, a number x is greater than 8, greater than negative 8, and is a key word when working with compound inequalities, and it's less than or equal to 4. So x is less than or equal to 4. All right, now whenever two inequalities are combined by an and, you could create a compound inequality by combining the two. So we start with the smaller number, negative 8. We end with a bigger number, 4. X goes in the middle. And this part is easy using this information because I just take the same inequality sign. But for this one, since I'm flipping the terms around, I need to also flip the inequality sign. So there, I've combined the two inequalities into one. And if I wanted to graph this, it would look like this. Negative 8, 4, and we're starting at negative 8. All right, now reading this from right to left would be x is greater than negative 8, so I'm going to the right. And then it stops at 4, but it also includes 4. All right. If you need any extra clarification here, please make sure to ask. For part B, a number y is at most 0. At most 0. Okay. So y is at most 0, meaning it can't be greater than 0. So it has to be less than 0. But it says at most 0, so it could also be 0. So y is less than or equal to 0. Or, that's another key word, at least 2. So at least 2 means 2 or greater. So y has to be greater than or equal to 2. And now when you're working with an or, you're not going to combine the two inequalities because you're going in different directions. So let's graph this, and what do we get? 0, it's less than or equal to, so I start off at 0 and I go to the left. And for 2, it's greater than or equal to, so I start at 2. Let's fill it in because it's equal to, and I go to the right. All right, don't forget to fill in this dot as well, because for both of them, it's equal to. All right, that's all you have to do for these. Going on to the next example. Key idea, once again, and you can combine the inequalities or you keep them separate. All right, solve each inequality, graph each solution. All right, really simple stuff. What would you do if this wasn't here? Okay, you would just add 2. All right. What would you do if that wasn't there? Well, you would just add 2. All right. So now we're just combining the pieces of information, but the strategy is still the same. Add 2 to both sides. All right, since you have two inequalities combined into one. All right, that cancels out, and you get negative 2 on the left side. You get x, and you get less than 5. All right, and that's it. We've isolated x. Let's graph this now. So starting at negative 2, we end at 5, and it starts at negative 2. It doesn't include negative 2 though. It goes to the right because x is greater than negative 2, reading it from right to left, and x is less than 5, reading it normally from left to right. So it stops at 5, and it's an open circle. All right, there's our graph. Going on to the next one, same strategy. Subtract 1 from both sides. Oops. And you get negative 4 is less than negative 2x. Is less than or equal to 8. Divide by negative 2. All right, be careful now. What happens when you divide by negative? What happens to all the inequality signs? They flip exactly. So flip the sign. Okay, now notice that the smaller numbers on the right and the bigger numbers on the left. So I have to switch everything around right now. And when I switch everything around, that flips the signs. Okay? So it's a matter of like, I just rotated this whole thing around. Okay. So -4 is on the left, 2 is on the right. X is greater than or equal to -4. That's what I have here. And x is less than 2. X is less than 2. Okay, I'm good. All right, and then graphing this, I have -4 and 2. -4, I start there, and it's a solid circle. And go to the right, and then I'm at 2, open circle. All right, going on to example 3. All right, solve the inequalities. Okay, they're connected by an or, so you gotta keep them separated. All right, so we have +5, 3y is less than -3. Divide by 3, y is less than -1. All right, next one, I'm gonna add 1. Then I have 2y is greater than 6. Divide by 2, y is greater than 3. And they're connected by an or. All right, if I graph them, they're going to go in different directions. -1, it's less than, so open circle and going to the left. For 3, greater than, open circle, going to the right. All right, that's all we have to do. Going on to the last example. All right, for example 4, we have a word problem. Okay, don't freak out. Electrical devices should operate effectively within a specified temperature range. Outside the operating temperature range, the device may fail. All right, write and solve a compound inequality that represents the possible operating temperatures in degrees Fahrenheit of the smartphone. Okay, well, here they give us the operating temperature in degrees Celsius. So it's from 0 to 35. Okay, now recall that the formula for Celsius is 5/9 times Fahrenheit minus 32. That's less than or equal to 35. All right, so Celsius is equal to 5/9 times Fahrenheit minus 32. Okay, so now I'm going to convert, and I need to get f by itself. What am I going to do? All right, we have this fraction here. How do we get rid of the denominator? Multiply all sides by 9, exactly. All right, so this cancels out here, and we get 0 is less than or equal to 5 times f minus 32 is less than or equal to 315. Okay, this isn't that bad, right? See, easy math. All right, now how do I get rid of this 5 here? Two things you could do. You could divide by 5, or you could distribute, your choice. I will divide by 5. All right, so I have 0 is less than or equal to f minus 32, which is less than or equal to 63. All right, now I just add 32. So I have 32 is less than or equal to f, which is less than or equal to 95. All right, so there's the operating temperature in Fahrenheit now. All right, so from 32 degrees Fahrenheit to 95 degrees Fahrenheit. That's the answer to part A. And for part B, describe one situation in which the temperature could be below the operating range and one in which it could be above. All right, well, you could be in, like, for example, Antarctica, where it's super cold, and that would be below the operating temperature. Or you could be, for example, in the desert, and you'll, if it's very hot at that time, you'll be above the operating temperature. So that would answer part B. There are many different correct answers to part B. All right, but the most important thing is to understand how to do all this. All right, but it's not too bad. You have the skills to do this now. Just take your time working it out. All right, begin the assignment at the bottom of the web page. Make sure to ask questions if you have any.